Okay, so where I'd like to start is just to kind of revisit some of the stuff that we did with the recur. Hold on. Oh, there we go. Okay, I thought the audio died. One more example of the recursion, um, just to kind of help you guys sort of think about the homework exercises for this. And so let me start by just writing a simple little program. And then we're going to run it and see what happens. But more importantly, I want to kind of look at um, why it does what it does. Um, okay, so let's do new file. Okay, so okay, so I've got this simple little function that I've written. Okay, and first off, is it in fact recursive? Yes. Why is it recursive? What's sort of the definition of that? Yeah, the function's definition refers to itself, okay? Now, we also have, this looks a little different than the recursion for the towers of Hanoi, okay? But we do have a bit of a potential problem, okay? Um, which is that the recursion could theoretically go on forever, okay? Now, that won't actually happen in this example, and let's think about why. The recursion only happens, so we call exercise of n plus 1, okay? That, because the number n is actually getting bigger, we do have sort of the theoretical possibility of just sort of running away with this. But under what circumstances does this line actually get executed? Only if n is less than 3. That's our catch to make sure that we don't recurse off indefinitely, okay? Because if n actually equals 3, then that if condition won't execute, and so the recursion will sort of stop, okay? All right, so first off then, let's just run it and see what happens. Let's see, so I need Python 3 and from rec1 import star, and then I need to call the function with some sort of input. Okay, so I called exercise of 1, and it ran and printed this sequence of 6 numbers. And what I want to kind of look at on paper is why these are the 6 numbers, okay, but also why they're in the order that they are in, because it may seem counterintuitive at first, okay? Okay, good. All right, so let me just copy the program onto the iPad. All right, so what did we have? We had def exercise of n, and that was print 2n. Then if n is less than 3, exercise n plus 1, and then print 3n. Okay, let's also be cognizant of, and dang, Thomas, you didn't skimp on the ketchup this morning. I can smell it from here. Apparently, this is Professor McKinney's CS-101 and breakfast cafe.
I didn't want to be late. I'd rather be here than late.
Yeah. Well, next time you got to bring everybody breakfast.
Oh, I can do that.
Mm. Or we can just have Travis set up like an omelet station over there while we're teaching. That would be,
Yeah.
yeah.
That
Would,
sounds like a good.
wouldn't it all be distracting or anything?
No.
Yeah. So, okay. So this print 3 in line. Let's be clear. Does that when does that occur?
All the way at the end after.
Yeah. Okay. Sorry. I didn't really word the question very well. Does the printing of 3 in have anything to do with whether or not n is less than 3? And how do we know that? Because it's not indented, right? So the print 3 in is not indented, and so it's not part of the if condition. Okay, just want to make sure we're clear on that. Okay, so let me go over to the iPad and make sure that the stream is actually capturing it, which of course it is not. Oh, there it goes. Okay. Okay, so I just copied the text of the program over, and then I kind of want to look at how would we sort of determine or run this thing on paper rather than with actually using Python. Okay, so what did I call here? I called exercise of 1, right? All right, so that's where I started. And what does exercise of 1 say to do? Okay, the first thing it would print 2 in, and what's in right now? 1. Okay, so I'm going to print 2, and then I'm going to say, is 2 less than 3? Or sorry, is 1 less than 3?
Yes.
Yes. So I'm going to compute exercise of what? 2. When that is complete, what am I going to do?
Print 3.
I'm going to print 3, okay, because right now, n is equal to 1. Okay, does that make sense? Okay, so what this should explain is what was our sequence of things that got printed? In fact, let me just switch over and copy that down. It was 2, 4, 6, 9, 6, 3. Okay. So, does this explain 2 of the numbers?
Yes.
Yes. Okay. The 2 and the 3, and the reason that the 3 is at the all the way at the end is because, well, exercise of 2 is going to do a whole bunch of stuff, right? And it has to complete doing all of that stuff before 3 ever gets printed. So this explains 2 things. Why, well, we see 2 and 3, okay, great, but also why 2 is at the very beginning and 3 is at the very end. Does that make sense?
Mm-hmm.
Okay, 2 being at the very beginning, that probably is obvious, right? 3 being at the very end, well, maybe not at first, but now is, does that make sense? Question?
Yeah,
No? Okay. You're kind of giving me the, I'm about to ask a question look.
Yeah, sorry,
Yeah.
Let's just look that up time. Ask Dr. Williams from the music department about it.
Uh-huh.
It's a running joke.
Okay. Well, it could be worse. I did have a student a few years ago that he'd always sit kind of like right in the front couple of seats, and he had the absolute most textbook example of RBF. And no matter what I said or did, he'd always be sitting there looking at me like he just wanted to murder me on the spot. And it was just, yeah, it was so intimidating.
Was it 8 a.m.?
You know, I don't remember. It very well could have been.
Yeah.
Hey, did he ask you to give him tea?
He was staring at me.
Oh,
Yeah. He was giving RBF.
okay. All right, so exercise of 2 is going to run, and, oops, for that, what is in? It's actually 2 now, because I'm calling exercise of, well, 2. All right, so what does exercise of something do? It first prints twice the something. So what's going to get printed? 4. Okay, and then is 2 less than 3?
Yes.
Yes. So it's going to call exercise of 3. And when that is complete, it's going to print what?
6.
Yeah, print 6. Okay, so this also then explains the 4 and the 6, and you see how we're kind of working from the outside in? And this is sort of the oniony kind of structure of recursion. And then finally, if we do exercise of 3, well, the first thing that happens is we print 6, because that's twice 3. And then is 3 less than 3?
No.
No, so this is where the recursion will stop. And then, but I will print 3 times n, which is 9. Okay, so I've drawn the sort of lines here to kind of indicate the sort of oniony structure of this. But what is going to happen? Well, I print 2, and then I'm in the midst of exercise of 2. And then I need to print 4, and I'm in the midst of exercise of 3, where I print 6, I print 9. I finished exercise of 3, so what do? I print 6. Well, now I finished exercise of 2, and I print 3. Okay, so what's the order? 2, 4, 6, 9, 6, 3, which is, of course, exactly what we saw. Okay, but this is sort of explains it on paper why it is that order. Okay, now, this will take some practice, and what's the best way to practice things? Doing fun and exciting assignments on Canvas.
Joy.
Yes. Huh? Well, I mean, how else do you learn, right? You learn by doing, not by watching me sit up here and do it, right? Like, suppose that you were in a class called weightlifting, and your final exam was to bench press, I don't know, 200 pounds. Is that a lot to bench press? I don't know. But like if you trained all semester, could you do it? Okay, so let's say I'm in a class and my final exam is to bench press 5 pounds. Okay, which is going to be what, the weight of the bar or something. Well, if I just sit and watch my weightlifting instructor bench press all semester, then what's going to happen? I'm not going to get it because I wouldn't have done the hard work to grow those muscles, right?
Similarly, we have to grow our brains.
Yes, for which we have Canvas assignments. Okay. All right, so just wanted to kind of go through that, and this probably isn't the only way to write this sort of thing down, but I found that this kind of unpeeling sort of structure makes it a little easier to see what's going on, okay? And maybe the part here that's most frustrating or can be confusing is the fact that the value of n is changing based on where you are in the current execution, okay? So this is why I wrote, kind of by organizing it this way, I can keep track, okay, right now n is 1 or 2 or whatever. So, yeah. If anybody can come up with a better way of doing this, I'm all ears. This is the best I've come up with thus far. So, okay, Gucci? All right, so the next thing I want to do is just kind of to tie off a loose end, which is, let me actually, for sake of demonstration, go back to the computer. And let me just open up a terminal here, and I want to just kind of, let's see, we'll go to programming. Let's go to the CS-101 directory, and let me list all the files that are there, and actually let me list it this way. Okay, so there's a whole bunch of things in this folder, right? Bunch of files, okay? And I've just listed all of them out in kind of detailed view. And what I want to kind of look at in particular is how much data actually is there for all of these different files. Okay, so first off, which column am I looking at? Yeah, this one here, okay, which tells me, in this case, how many bytes each object takes up, okay? And there are two of them that are maybe special. The ones that say that they take up 4096 bytes, those are actually directories, okay, not actual files. And so the directory takes 4096 bytes to kind of store its properties as a directory, but it's not actually a file, okay? And all of these other ones are, well, relatively small, right? A few hundred bytes at worst. Now, that's a pretty small amount of data, but let's compare this to, let me take an example from my other class. Okay, so in this case, there's a program that we wrote, and it is 601,000 bytes and some change. Okay, now, how do we talk about large numbers of bytes is basically the question here. Okay, yeah, what are the units that we use for talking about large amounts of data? Megabytes, kilobytes, gigabytes, and so on, okay? And so what I want to look at is actually what is the formal definition of all of those things, okay? Now, for that, let me go back to the iPad, and then we'll come back to the computer at the appropriate time. Okay, so first off, let's make sure we're clear. The smallest unit of information that you can have, of course, is a bit. It's either a 0 or a 1. That's it. 4 bits is called a nibble with a Y. Okay. If you're typing this, by the way, just warning, because it'll probably try and autocorrect nibble with an I instead of a Y. Okay, fine. 8 bits is a byte, again spelled with a Y, not an I. I'm actually not sure why, pun intended, we spell it with a Y. Like, there's got to be a good reason from back in the day, but I don't actually know that story. I mean, it does. It looks cool, huh? Maybe. Yeah, but like, why did they call it a byte in the first place, right? As opposed to, well, like in French, for example, it's called an octet because it's 8 things, right? So, makes sense, right? Okay, so if we have large numbers of bits or bytes, okay, what are we going to start calling these things? What would make sense if I had 1,000 of them? Kilo would make sense, right? That's the metric prefix for 1,000. Okay, but historically, let me make sure I've got the number right. 1, 2, 4, 8, 16, 32, 6. Hold on 1 second. I'm having a derp moment this morning. Yeah, okay. 2 to the 10th bytes was a kilobyte. This is 1024. Okay, so back in the day, right, wouldn't it make sense to take units of these things not in powers of 10, but rather in powers of 2? We're on a computer, after all, where everything's powers of 2 anyway. Yes? Okay, so the power of 2 standard became the standard, right? That, all right, I'll use 1024 as the first unit of a bunch of things. So I'll call 1024 bytes, I'll give it a special name. Well, 1024 is pretty close to 1,000, right? And so whoever made this up decided, okay, I'll call 1024 bytes a kilobyte. Okay, now there's a bit of a problem there because kilo as a metric prefix means what? 1,000, not 1024. But it's only 24 bytes, right? Okay, so the convention stuck, and then if we keep going, 2 to the 20th bytes is 2 to the 10th kilobytes is 1 megabyte. Okay, and this, by the way, is 1,048,576. Which is still pretty close to 1,000,000, right? It's not maybe as close as 1024 is to 1,000, but it's close. Yes? Okay, so this was a megabyte. It's 1024 kilobytes. And then we can keep going up the chain. So 2 to the 30th would be 2 to the 10th megabytes. And this is what? Yeah, a gigabyte. Okay, and so on. So 1 gigabyte, well, that's a crap ton of data. What's the next one up? 2 to the 40th is 2 to the 10 gigabytes equals 1 terabyte. Okay, and what's after tera? Anybody happen to know? It's petabyte. Yeah. And then exabyte. Okay, but we'll stop at terabyte. You get the idea here. And every time that you go up, you went up by a power of 2, or a factor of 2 to the 10th. Okay? Now, let me stress that this is the historical convention, but it still gets used half of the time. And to demonstrate this, let's go shopping. Shall we? Okay, so let's go shopping. I want to buy a hard drive to store data. All right, so I swear I'm not getting, this video is not sponsored by Newegg. Okay, but Newegg is where I buy basically almost all of my computer parts when I'm buying computer parts. And if the website will load, it's probably a little slow because I'm on Chromium. All right, so components. Let's buy a hard drive, shall we? Let's buy a desktop internal hard drive for my sweet big gaming rig. And I don't know, let's say that we want 4 terabytes because I want to download a whole bunch of illegal anime or something, I don't know, right? Now. Oh, here we go. Perfect. This Western Digital will do. Yeah. Well, because it's Newegg, right? So the rating system is in terms of eggs. Okay, so we've got a nice nice big hard drive here. Okay, how many gigabytes is it, or terabytes? 4. Oh, but you know, okay, so here's the product information, right? We can get this particular model up to 10 terabytes. This is the 4 terabyte one. But what do we have here with terabytes? The dreaded footnote. All right, So what's the dreaded footnote? Well, let's click the dreaded footnote. Okay, well that's not the dreaded footnote that I was looking for. Ah, here it is. There it is. Okay. This is interesting. They actually have a typo. So, as used for storage capacity, 1 gigabyte, and then they have a less than symbol for some reason. That shouldn't be there. It should be equal. 1 gigabyte is 1 billion bytes, and 1 terabyte is 1 trillion bytes. Well, okay, so what system are they using here for giga?
The actual meaning of it.
Yeah, they're using the metric meaning, okay? And as we saw, the metric value, right, so what's 1 billion versus 1024 cubed, I guess it would be, right? So there's a difference there, okay? Which is why, let's say that we bought this, and I plugged it into my computer, and I formatted it, I would have like 3 point something terabytes. And I'd be like, you jerks, Western Digital and Newegg have ripped me off, okay? Because I bought a 4 terabyte hard drive, but it actually only reports that it's 3 point whatever terabytes. Well, the reason is this discrepancy between the base 2 system and the base 10 truly metric system. Okay, so in the industry, you still see it both ways. The storage manufacturers tend to do this with the base 10 system. Everything else tends to be the base 2 system. So if I went and picked out like some RAM and it said it was 64 gigabytes, it actually is 64 true gigabytes. Okay, meaning 1024 base system. How many of you guys find this irritating and confusing and you want to go punch somebody? Not the best system?
It makes perfect sense that these storage people would use base 10 system. Sounds a lot more aggressive that way.
Well, yeah, because they can sell it for more than it actually, you seem it is, yeah.
Some use that, like, they'll report that, but they're actually, if you put on that storage, they use that for swap space. Some do.
For,
Like,
uh,
some use the report as the actual size, and then like, take the 24 bed, and however they do swap space.
yeah, now, the other thing is it depends on which operating system you're using because nowadays, I think both Mac OS I know has, it refers to the gigabytes and stuff using the metric bases instead of the other one, because they were tired of basically people coming into the Apple store being like, why does it say it's blah 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 when it's actually blah blah blah? And so they just changed the way it displays.
They couldn't give them a history lesson?
Well, I guess, right? Okay, but there is. Yeah, exactly. Sit down over here. Yeah, there is actually a different solution to this problem, though. Okay, and for that, let's go to the bastion of all knowledge of Western civilization, Wikipedia.
So does the discrepancy between base 10 and base 2 measures of these things ever create any like problems with making or building stuff?
Not really. Just you have to be aware of it, right? So, yeah. Now there is a sort of solution. Okay, so let me go to byte here, okay? And this table is what I want to look at. Okay, so here's sort of the fix for it, okay? Which is in terms of memory storage or data storage, the data storage people all use the metric system, the metric values, okay? And, you know, if we want to be consistent with, of course, the rest of the metric system, we do have to admit that using kilo to mean 1024 in computer contexts, but not in every other context under the sun, is not ideal, right? The whole point of the metric system is to be standardized and for there to be no question what you're talking about, right? And this flies in the face of that. Okay, so somebody came up with, all right, well, we get why they would have called this kilobyte, because it's close to 1,000. But we don't want them to use the actual word kilo, because that has a specific meaning. So let's come up with a thing that looks and sounds a little bit like kilo, but isn't actually kilo. And similarly with mega, giga, and so on. And whoever decided to make it, okay, we'll call it a kibibyte, and a mebibyte, and a gibibyte, and so on. Okay, now, that sounds ridiculous, right? If you want to get, like, you want to find your party having a ratio that's undefined, okay, or infinite, depending on which way you do the fraction, okay, then refer to the number of kibibytes of beers that you're going to have at the party, okay? You guys get, it was a ratio joke? Yeah. Huh? Yeah, if there's no women, then the ratio is either infinite or undefined, depending on which way you think about it, right? Because you can divide it by 0. Yeah. Thomas?
Or if you have the ratio the other way, then it's 0.
Yeah, it's more fun to say the ratio is infinite. It's more patchy. Okay, so I personally find saying the word kibibyte, it just grates at my soul. Okay, and part of this is because I'm old-fashioned, right? When I started learning computing, you know, back when we had to walk uphill both ways in the snow to school and you know all that stuff, right? It was just the 1024 base system, and it was kilo, mega, and so on, and just everybody got on with their lives because this isn't rocket science. Not really the case today, okay? And so if you see basically for storage devices, hard drives and such, gigabyte actually genuinely means the base 10 system, okay? But with RAM, processors, basically everything else, it means the sort of pseudo-metric kilobyte and so on, okay? Now, some operating systems do build this in, okay? And for example, let me go to just a different directory. Let's go to, oops. There's nothing in user local bin. Okay, that was surprising. Oh, there we go, okay. So it's in user bin, not. Okay, so here it's displaying in just the number of bytes, but there is actually a command, and in fact in some contexts, like on my Mac, I think, it will do it the other way, where it will actually show me in giga or whatever. So let's actually do the let's see. Here we go. So we can tell it to use, for example, -K for kibibytes, so let's do that. Oops. So let's find something. Why didn't it do that? Okay, let's go back and try this again. So let's see. Kibibytes only used with dot, oh, dash S, okay. There we go. Okay, so here it's actually displaying everything in kibibytes. And in some cases, it will actually print the unit and say it's so and so many kibibytes, and it'll have the prefix, which the prefix is, oops, that's not the button I meant to hit. The prefixes for this are KIB, MIB, and so on. And one thing that yeah, so basically they just take the metric prefix and put an I after it in terms of the prefix, and then that's how you know if it's a kilobyte versus a kibibyte or whatever. Okay, is that all right? All right, now, this, because both systems are still technically in use, but also because I'm old school, okay, I, like, for example, Canvas exercises and stuff, I've usually defaulted to the 1024 base system, and I've been using it for so long that it's automatic, okay? This would be maybe the best comparison for you guys would be, well, if I told you however many kilometers it is to Indianapolis, you'd be like, okay, great. Would you know how long it would take you to get there?
But I guess it's
Huh?
that's the same time.
Well, it's the same time regardless, okay, but like, you pretend that you didn't know how far it was to Indianapolis, right? If I told you in the metric system how far it was, okay, most of you would be like, what's a mile or kilometer, right? Yeah, exactly. Yeah, so.
I would multiply by 3 and divide by 5 and convert into miles that way.
Okay, yeah, you could do that, right? You could do the unit conversion, be like, oh, well, what is this in miles? And then off you go. Okay, great. But point being, right, you don't intuitively have a sense for metric units in basically any way, shape, or form. Now, the one exception to this would be, well, those of you guys who are lab science majors, right, because how do you measure everything in the laboratory? You're using metric everything there, but you don't use it in kind of your everyday life, okay? If you did, then, well, you would just be used to that system instead. So, imagine like that you grew up here in the United States where you grew up with this sort of non-metric system, okay? And then suddenly the country, this will never actually happen, but let's just suppose that the country wakes up one morning and says, you know what? We're going metric. Okay. First off, that will never actually happen because America. Okay. But second, suppose that we did that though, right? What would be the case for like 50 years after that decision? People would be very confused, particularly anybody who had significant life experience from before the change, right? So if we wanted to make the change and do it right, what we would do with like road signs and stuff, for example, is
Display things in both.
we put them in both, okay? And here's McKinney's, the gospel according to McKinney. Brilliant way of doing that. You say, okay, starting on January 1st, all new road signs that go up have to have the miles first and the metric in parentheses. 10 years after that, all new signs that go up have to have the metric first and the miles in parentheses. And 10 years after that, you just put the kilometers, and that's it. and then eventually it would all get straightened out. Okay. Now that said, there was a famous incident when the switchover happened, which, because we're on the bastion of all knowledge of Western civilization, let's look at the Gimli glider. Okay, or the lamer name is Air Canada Flight 143. Okay, so it landed at Gimli, Manitoba, without its front landing gear for reasons that will become clear. So basically, what happened is this happened right after right after Canada fully metricized. And what happened was they were going to be loading a particular number of pounds of fuel, okay, and they loaded kilograms of fuel, and kilogram and pound are not the same thing, and so the plane only had about 45% of the required fuel to get from point A to point B. So it's about halfway in its cruise, and all of a sudden, it runs out of gas. Now, what happens if you're driving and you run out of gas? Does this actually happen to anybody? Yeah? What do you do?
Oh, I don't know, my finger grabbed it.
Oh.
You kind of just pull over and then stop.
Yeah, you just kind of pull over, right? Well, you know what you can't do? Pull over an airplane that's going 600 miles an hour. Okay, it doesn't work that way. And in particular, right, commercial airliners are not really designed to glide. I mean, they can, but they're designed to have at least one engine working, right? And this one suddenly had zero. Okay, the most recent incident of this, although different cause, was, how many of you guys have actually seen the movie, what was it called, Sully?
Yes.
Right? I remember the day that happened, right, watching it on the news. Were you guys alive yet? That was what, like 2009, somewhere in there? 08? Were you, well, you guys were alive. Okay, does anybody, yeah, you don't remember it probably. Okay, similar thing happened, right? Suddenly the guy lost both engines, and in his case, he was really screwed because it was right after takeoff and he was in New York City. So it's not like you just kind of pull over on the side of the, you know, or land on a highway, right? And so he had to ditch in the Hudson River, and by the way, it was January and freezing. Now, this one in Canada, right, it ran out of fuel, okay, and so suddenly he has to glide, and he happens to know that there's an old Royal Air Force base that was that he just happened to know about from his time in the service, and that's where they landed, okay? And it turned out, you know, everything ended up okay. I think there were some injuries, but nobody died, okay? But that came basically from a horrible unit conversion problem between, in this case, pounds of fuel and kilograms of fuel. So I am not aware of any such incidents like this that relate to the 1024 versus 1000 problem, okay? But would you guys agree it's a problem?
Yeah.
Okay. And it is one where I'm going to slip and I'm going to always default in the back of my head to the binary system because that's the system well, A, it's still in use, and B, I've been using it for so long, it's second nature. It's as second nature to me as you guys using miles and Fahrenheit and whatnot. Yeah? Okay, so with respect to Canvas, I've tried to code it, I think, so it'll take it either way, but if in doubt, just default to the 1024 base system, and we'll call it good there. Okay? All right, so the last thing just here, because we got a couple minutes left, is My plan for Wednesday is to do another reading discussion, so I'll send that out onto to you guys via Canvas here later today. And yeah. Question, preguntas, fragen? We'll also have our first exam after break, and I'll maybe just mention briefly some slight details on Wednesday. It won't be on Monday right after break, so don't worry. I'm not going to be that guy. Okay. So, all right. See you guys later.